Yeah. So let me, yeah, because a lot of things I need to talk about. So, yeah. So let me write a few things here. Yeah. First, regarding project 2. Yeah, project 2, right now I'm posting videos. Yeah, but I just finished the preparation part 1, part 2. Starting from today, I will post a sample project, sample code. Yeah, so that's the directly working on the features of the project. Yeah. After a few times, you will get most of the features. Okay? Yeah. So for project 2, one thing I like to update, because if you look at the current deadline, that's this Sunday, right? As I remember, I set the current deadline, December the 3rd, this Sunday. Yeah. But I like to give you extension 1 week, 1 week extension. Yeah, because this week I can complete posting my sample code. But you need some time, digest, understand, and complete. So I like to give you extension to just 1 week extension. All right? Yeah. Just to let you know, yeah, I haven't changed deadline, so I will change. So in that way, I hope, for beginners group, you try to make it by the deadline. Although after deadline, I still accept it. Yeah, but you may get a small, not big, small, penalty points. Yeah. All right. So that's project 2. Then, the remaining coursework, my plan, so give you, because we just complete homework assignment number 2, and we need to do homework assignment number 3, and we have also 1 quiz left, all right, 1 quiz left. So here, I plan to do this way, because I don't want to give you too much work to do, okay? Yeah. I try to first give you plenty of exercise, practice, but at the same time, do not give you too much work to do, because in the final stage, a few weeks, you have a lot of work. Other courses. So I try to reduce as much as I can. All right. So what I like to do, I combine these 2 assignments as 1 assignment. Okay? Yeah. Homework number 3 and quiz number 5 as 1 assignment. Remember, as usual, our homework assignment number 3, usually we have 25 questions. And quiz 5, we have 10 questions. All right, yeah. So now, I plan to do this way. Yeah. After we combine, we do 10 plus 10 questions, 20 questions. 10 plus 10 questions. Okay, all right. The first 10, we treat it as two rows, quiz 5 first. Second, also, it can be used as 3 part A. Okay, yeah. So that's the concept questions. All concept questions. Okay, yeah. So I will give you soon, yeah, soon, yeah. Yeah. Before Wednesday, or by Wednesday, let's say by Wednesday, okay? Our last quiz, and at the same time, we use it for homework assignment part A, number 3, part A, okay? Then, part B, 10 questions, 10 questions. That's the homework 3B. That's the query questions, all query questions. Query questions, okay? 10 query questions, and I split 5 plus 5, all right? So what do you mean 5 plus 5? The first 5, relatively easier, okay? Or we treat as basic query questions still. So let you practice a little more on the basic query questions. And 5, a little harder, so we can call it complex questions, query questions. So that's what we are going to do this week, okay? This week, complex query questions. But in order to, to not give you too much work, so the complex, you just do 5 as practice, Yeah, because the reason in our final exam, here, we get to final exam, right? Yeah. 25 questions. Okay. All right. 25 questions we split in this way. Part A, Part B. Okay, yeah. Part A, Part A, this 15 plus 5. Part B, 5. So what's that? All right, so let me explain. 15 concept questions. All right. 5 basic query questions. Basic query questions. Okay, yeah. And these 20, part A, we do in class, okay? In classroom, in class. Right here, all right? Yeah. All right. 2 hours, on the syllabus, the time, date, time on syllabus, 2 hours for part A. Part B, because part B, that's the 5 complex queries. Yeah. relatively hard. Yeah. You may need more time, okay? 5 complex queries. Questions. So this one, you work at home. Okay? Yeah. So that's the final. Yeah. So this arrangement. But before that, yeah, because these, remember these 2 weeks, yeah, this week, next week, basically what we are going to do, review. Yeah. Because today, I will finish the indexing part today. Then start complex query, all right? So a few examples. Yeah. And Wednesday, I like to give you more complex query examples. Yeah. To give you plenty of complex query examples so you can study. Then you practice. Yeah. You know, the final you can do at home, all right? So not in class. Yeah. Class, relatively easy query questions, basic query questions. Yeah. So, all right. And so that's the arrangement for our final review, test, that period. Okay? Yeah. 3 weeks, that period, 3 weeks period. Yeah. All right. Any questions? Yeah. Yeah. Hope this arrangement, yeah, yeah, because actually you have a lot of work. Even if we do this arrangement, you know, you have a lot of work. Okay? Yeah. Because the project part, so I try my best to help, you know, students. Project 2, after I finish it, I need to help some students in project 1 a little bit. Okay? But at the same time, a few students, they like to do some extra credit project number 3, so I will make that one quickly. Yeah. But those for small number of experienced web programmers, they may like to try that. Yeah. Not too complicated for those experienced. It's not that too complicated. Yeah. Yeah. But you know, for beginners, yeah. So it's hard for the beginners to do those things. Yeah. So that's pretty much you know, for the remaining of the semester. Yeah. All right. So if you have any question, just let me know. Yeah. 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 So this slide, so that gives everything we need to do in this, you know, the last stage. All right? Okay, so yeah. Then let's move to our index topic. Before I start the new material, so remember, I need to recall, so I need to talk about this primary indexing a little more. We know this type of indexes prevalent, you know, we can assume 90% of the time cases people use this primary index, approximately, So that kind of popularity, all right, But there are, so other than the primary indexing, there are 2 more others. So I will not go to too much details for the remaining 10%, but I just let you know what are those indexes. All right. So there are three types of index files. The first one, primary. Second, cluster. Cluster indexing. Okay? The third, secondary. All right. Yeah. Here, I like to give you, detail, just how, under what situations do we use these indices? Yeah. So for the primary case, yeah. So you need to have a indexing key field. Before you can build, construct, define this type of indices, you need to select index key field. So that is just so what is the index field? What field can we use as an indexing field? So that is one of the key fields of a table. Okay? Yeah. Yeah, because, the last time, previous lecture when I talk about that, I said the field may not be a key field. Actually, that's not correct. So then later I said, we delay that. Remember that? Yeah, because when we talk about other indices, then we come back to answer that question. Here, that's the time. Here, remember, it should be the key field. What do you mean the key field? Very easy, unique values, right? We require a key field with unique values. All right? So here you can see this requirement is very important for the primary key indices. Yeah. Unique values. All right? Then, because for this indexing key field, when you define primary index, this field would become the primary key of the primary index. See? Yeah, because this key field, when we look at inside the primary index, we call it primary key of the primary index. Good? Yeah? Do not get confused. Do not get confused. Yeah. All right. Here. So the reason I spend this much time to clarify this kind of confusion, because it's important. Remember, currently, we are in a big data era, right? Think about, the industry, IT industry. So big data is very hot, the topic, big data. So we are in the big data era. And to do the data science related project, work, data science, the SQL is a must. You have to be familiar with the SQL, Okay, so this class, very useful. Yeah. Because if you do not understand SQL, you cannot do any data science project work. Okay, yeah, so that's important. And to manipulate data efficiently, this indexing technique is very important. Yeah. So this topic closely related to data science, big data. Okay? Yeah. Although we cannot go very deep in this topic, yeah. So, but the basics, okay? Yeah, the basic concept. Yeah. So the SQL we try to practice as much as we can. Okay? Yeah. So right now you're doing that. Then indexing, at least we understand, some basic level a little better, right? Yeah. Because if you need to go deeper, then you need to study by yourself. With this background, this preparation, you can, go much deeper from here. Okay? All right. Yeah. So here, let you know the importance of this topic. Yeah. Another thing is, I just searched the web. Yeah, we know on the web some tutorials talking about this topic, but I saw one, so I noticed that the description in that one, Google search pretty high. So I just searched the primary indexing, very top, very high. But I noticed the description there not correct. Why not correct? In that one, in that document, it requires this field. Here we know this field, one of the key fields. In that one tutorial, it says it must be primary key of the table. We do not require that, right? Yeah. So that, the author of that article, it requires, in order to define primary, you have to use primary key of that table to define. That's incorrect. Okay? That's a big mistake. Big mistake. And here, so this is correct. Yeah. But it must be a key field. No problem. Unique values, no problem. But it could be a secondary key, not primary key. Although you can use primary key to build primary index, it's fine. But you have more than one primary indices you can define for one table, because you may have multiple secondary keys, right, on the table, multiple secondary keys. Yeah. So I want to clarify that. Yeah. All right, yeah. Then clustering and secondary. Yeah. So let me explain a little bit. Clustering secondary. What type of keys we need? Yeah. Clustering, from the name, cluster, from the name, then, all right, yeah. The indexing so here, let me just, do not require the unique values. Unique values. Do not require the unique values. Now, here, unique values, right? Yeah, look at that, unique value. In other words, it allows duplicate values. Duplicate values, okay? Yeah. Because it allows duplicate values, so you may have, suppose, this is a table, this is the field that we use to build a primary key of the index. So if you can sort it. So people still sort it based on this field. Sorted, you can apply binary search, right? Yeah. But after you sort it, you can see the duplicated values will form clusters. See? Because back to back, a block of rows, they have the same values. So one cluster. Okay? So that's why, so, you may have many clusters. All right. So then, we define different type of indexes. We cannot use the primary key way, all right? Primary index way. Primary index way, yeah. So, remember we use anchor block, right? Yeah. Anchor block, yeah. We will see that. Yeah. Anchor block. Yeah. So that structure. So here, for the primary indexes, you have to consider the property. Many blocks, they can have the same value. In primary key, we don't need to consider that. Okay? All the keys are unique. So you don't have clusters. Okay? You do not have any clusters. All right? But here, you may have many clusters. Okay? In other words, you may have many disk blocks, many consecutive disk blocks. They may store the rows with the same value for this field. That could happen. Okay, many disk blocks. Yeah. Same values. Yeah. That could happen. But primary index, it would never happen. All right? Yeah. So you don't worry about that. Yeah. So that's a very important one. Then the secondary index. Yeah. Secondary index. So here. Yeah. Both cases you can do secondary. The secondary index, so the thing is, no sorting. Yeah. Because the primary cluster, when we build index files, we do sorting first on the key field. We do sorting. We will use binary search. Yeah, but here, yeah, actually, so here, here, yeah, actually here, yeah, here, sorry, here we do sorting, but, yeah, so here, yes, yeah. I get confused. Yeah, we do sorting, but one thing that's different from the primary key, yeah. But the property is one entry, index entry, corresponds to one row, one record in the table, original. Yeah. It has this property, okay? It does not jump, okay? Always one-to-one correspondence. Yeah. One index entry corresponds to one record in the original table. Yeah. So we call it dense index, dense. Yeah. Primary sparse. Yeah. Next slide we will discuss about the dense and the sparse indexes. Yeah. Because secondary, yeah. So we do sorting on the key field, but you can see with duplicate keys, you can do that. Duplicate keys. Yeah. The key value, so the key, the field value, duplicate values. You can apply secondary index on it. Because one-to-one, although the keys all have the same key values, field values, yeah, but they store different pointers. Because location of the record, yeah, because the entry, together with the entry, you have a pointer, right? Pointer points to the location of that record. Location. Okay? Yeah. That's the secondary. Yeah? So there are these three types. Yeah. In this class, we mainly learn primary. Okay? Yeah. But you only need to know there are two other types of indices. Okay? Yeah. All right. So let's move to next. Let's look at the details for the dense index and the sparse index. Okay, yeah. The dense index has an index entry for every search key value. Okay? Every search key value, and hence every record. Okay? So one-to-one correspondence. One-to-one correspondence. Okay? Yeah. In the data file. And we do not require unique values for the search key field. For the search key field, it allows duplicate values. The reason is simple. With duplicate values, you can still sort the table based on that field, right? Yeah, because we can sort the table on the field with duplicate values. Okay? Yeah. And we can apply the binary search on it. On the index file. Okay? Yeah. Binary search on the index file. Okay? No problem. Still very fast. Yeah. All right. But here, why here we require one-to-one correspondence? One key entry for because. So the problem here is when we find some search key value, so here actually here there is a problem. Yeah, actually here, yeah, I think this may not be correct. Yeah, with duplicate key values, this may not be correct. Because with duplicate key values, we can use cluster index, right? Why we use this one? Yeah. So on the field, yeah, right? Yeah. The problem is because for the duplicate keys, if we do this way, then many key values are repeated. And how do we know the entry with certain key value corresponds to the correct record, right? You don't know it. Yeah. So this one still with unique. Otherwise, we just use the cluster index. We do not need to use this index, right? If we duplicate keys, then we need to organize in clusters. We need to design specific algorithms for clusters, right? So we do not need to use this way. Yeah. But if we use this way, then the question, same key values, how do you know which record is the one you want to search, right? Yeah. We do not know. Yeah. So, but with unique key values, you know, because based on the value, you know, that's the one you are searching for, right? Yeah. That's enough. But with duplicate values, you do not know, right? Yeah, you do not know. So you need to consider cluster. Okay. Cluster, the algorithm is different. The search algorithm would be different. Yeah. Here, I can talk about the search algorithm a little bit, yeah, because for the cluster case, you expect there are multiple blocks, consecutive disk blocks, B1, B2, B3. They may contain the key, the field values, same. So here, that's the clusters. These clusters, okay? Yeah. Same value. Same value rows, right? Yeah. Same value, yeah. For this specific field, same value, duplicate values. How do you know? So you have the value. How do you know which record is the one you want to search, right? You know, yeah. So which one? So then the algorithm, you need to load block by block into the main memory to do the search. Yeah, block, not just one block, because one block, you do not know which block you should load, right? So you should load the first block. If you cannot find the first, the record to be searched for in the first block, then you need to load the second one and do the search and so on. That will be, a lot, much more work you need to do. Otherwise, how do you know it, right? Yeah. So that's the cluster, that index. Okay, that index. Yeah. All right. Yeah. So here the dense. Still, we require a unique key field. Yeah, but here you can see. It does not say that, right? It does not say that. Yeah. Yeah. Probably it says the key value. When it says key, we assume unique values. That probably hidden way, implicit way to assume unique values. Yeah. All right. Primary index is not dense. Yeah, because we jump. Okay. Each block. For primary index, we only store one entry for each block. So that's why it's not dense. Why not dense? One entry for one disk block. Okay? because we want to make our search faster. Make our search faster. We want to reduce the number of entries, because this arrangement, we can reduce the number of entries. Reduce number of entries, okay? All right. So then, right, one thing is for one block anchor. Anchor, we know the meaning anchor. The first, what's that? Right. So the first record in the block, anchor, the block anchor. First record of the block, disk block. Okay? Yeah. All right. Sparse index. Sparse. Yeah. Primary index sparse. Yeah. So a sparse index has index entries for only some of the search values. Not all, some of, okay? Some of, we jumped, not all for all, okay? So we jumped, primary index we jumped, okay? All right. Comparison here, comparison, these two, a dense index is larger than a sparse index, because you have more entries. You have more entries. But a dense index supports unordered file. Unordered. So if you do not sort unordered, so it support. But here you need to know, for unordered file, you cannot apply the binary search. So, you need to be aware of it, because that's a big factor related to the search performance. This is a big factor, unordered, okay? All right. So that's these two concepts. Then let's look at this topic. Retrieve a block in a given primary key. So here we assume we are working on search a record in a primary index file. In a primary index through, so we want to search a record in the original table with the help of a primary index built on this table. So the complete sentence should be like this. Okay? Given a key, given a search key, and in this search key, the original key field, that's at least one of the secondary keys in the original table. It could be a primary key field or one of the secondary key fields. All right, so with that value, then suppose there is a primary index built based on that key field. All right, then, so let's look at the steps. How does a DBMS find the correct record of the original table for this type of index file? given a search key K of a record. Yeah. So key value K, the value equals that, so the K value. Okay? Yeah. Then assume that a primary index is constructed based on the field. Yeah. Yeah. So, do the binary search on the primary keys to locate the position. Primary keys, yeah, so here, remember last time I mentioned when you see primary key, this phrase, you need to determine which primary key we are talking about based on the context. Here, based on the context, this primary key should be the one in a primary index. Not in the original table. Not the primary key in the original table. Okay? Yeah, here. So, search on the primary keys. Yeah. So, here to locate the position. Yeah, binary search. Yeah. All right. Because you can find two adjacent primary keys. Yeah. Two adjacent. So what are two adjacent? One, the first one is K of I. Okay? Yeah. K of I. Second one is K of I plus 1. Okay? K of 1, K plus 1. Here, let me draw a diagram to show you. Yeah. All right. Suppose this is the primary index we're working on, okay? There are two fields for each entry. Two fields, all right, for each entry, like this. Yeah. All right. The first one, K of 1, pointer P of 1, okay? The second entry, K of 2, P of 2, pointer 2, and so on. Okay? Yeah. So here, K of I, P of I, K of I plus 1, P of I plus 1, and so on. Okay? Yeah. The K, the key value to be searched between these two adjacent primary key values in the index. Okay? Yeah, between. All right, yeah. All right. So you find that. All right. After you find that, because you have this I, right? Yeah, you have this I value. You know, our I value. Okay? Yeah. Yeah. So then, yeah, require that original data ordered on, yeah, indexing field. Yeah. So that's why we can apply binary search. All right. All right. Get the pointer P of I. Yeah. So because through the K of I, we can get a pointer P of I to reach the disk block containing the record with the key K. Yeah. Okay? Yeah. So this P of I points to a disk block. Okay? Yeah. Block. Okay? Yeah. Disk block. And it points to the location of the first record. First record. But when you load it, yeah, the record to be searched, it may not be the first one. So this, maybe this one, this record, somewhere in the middle of this block is the one to be searched for. All right? But you load the whole block, okay? You load the whole block, load it into the main memory. Then you get into that block and find the right one. Okay, yeah, so the remaining step, we will see that. We will see that. All right. Yeah, so the disk block containing the record with the key K. Yeah. But, so here, although containing that, we just go to the, location of this block, the pointer of this block, we load the whole block. Yeah. All right. Load the disk block into the memory, whole block into the memory. Okay. Yeah. Then find the record in memory. Inside memory, when we find it, so when you find it, you do sequential search. Yeah. Because you cannot do binary search. Right? Okay. So find the record using the linear search, not binary search. The reason is simple. These, the key values in this block may not be ordered, okay? Unordered, in general, unordered. So you cannot apply binary search, okay? Yeah. You cannot apply binary search, so you have to use the linear search. Yeah. But in main memory, we know it's much faster. Even the linear search, it is very, very fast. And the disk block not very large, remember? Yeah. So last time I gave you approximate number, the block size about 4K. Not too many records you need to search for. Yeah. Up to, it could be in hundreds of records. Yeah, that's already, relatively large number. Yeah. Within the 4K size, you cannot have too many records. Yeah. So that's the basic procedure to find a record in the original table with a primary index file. Okay? Yeah. So not too complicated. Not too complicated. Okay? Yeah. All right. Okay. Major problem with primary index. Okay. Although this is the most commonly used primary the index type, yeah. But there are a lot of problems. Yeah. So people can improve. People can improve it. Yeah. So here, let me just talk about some of the important one. One problem occurs when data is added and deleted. Yeah. So if you just do the sorting, yeah, directly arrange your index entries in sequential order, then insertion, deletion, usually pretty expensive. Think about that. Yeah. All right. A typical problem for ordered file. Yeah. When you need to insert, you need to make room for it, right? Then you need to, shift operation. You need to do a lot of work. That's very expensive. Yeah. After insertion and deletion, to recover the ordered structure, the cost is high. The cost is high. That means the whole operation slow. Okay. So slow operations. That's not good, right? That's not good. That could be improved. Yeah. That could be improved by advanced data structures and algorithms. Very challenging, but it's doable. It's doable. Yeah. So we will see that a little bit. Okay. All right. Change in the primary index. Now, people need to really do some important improvements here. Yeah. So the idea, move records to make space for the new record. Oh, yeah. So here, this is before the improvement. Okay? Before the improvement. How do you make the change? You need to move records to make space for the new record. Okay? So that's the change you need to do. The work. Yeah. Change anchor records in some blocks. You need to update. Now, anchor blocks could be changed, right? So you need to make updates on anchor blocks. All right, anchor records. Yeah. Anchor records. Change some index entries. Yeah. Actually, you can see these two relatively easy. Yeah. Because you just change update. Yeah. Change small number of places. But the first one is very expensive. This is making space, getting room for a new entry. Yeah. Move records. Yeah. Move records. Here, move records. So here, right. It is, yeah. All right. So actually, this record, it's better to use move entries. Right? Because I don't want you confused with the records in the original table, right? Here we do not move records in the original table. Here we move entries in the primary index. Yeah, right? Entries in the primary index. Okay? Yeah. Although you can call records, but strictly speaking, it's better not calling them records. Okay? Entries. Better calling them entries. Yeah. All right. Then, people really want to improve a more advanced data structure plus algorithm. Okay? Yeah, because after you design data structure, at the same time, you need to design algorithms. To manipulate the data. Yeah. All right. Yeah. Oh. Yeah. Before. Yeah. Because this topic I don't want to go too very far. Yeah. But I give you, the information. Yeah. Yeah. So B data structure B tree and B plus tree. Data structures. Two cases. And a B plus tree more, another round improvement. Yeah, B tree, improvement. B plus tree, more improvements. Here, let me describe these two data structures a little bit. I do not go too deep. Just general idea. So because the reason when we use this kind of special data structures, we can find the record to be searched for faster because we change from one level structure, one level because you apply binary search, that's the one level structure, right? Yeah. When you do binary search directly, so one level. But here, to multi-level. Structure. All right? Yeah. So you store your primary tree multi-level. So you have a root here. Okay? You start with the root. Under the root, you have, it's not a binary tree. Yeah. So you have, many nodes. That level, first level. Then second level, another, many. Yeah, second level, and so on. So you can see when you organize your data in this way, the bottom level, it could be, there are a large number of entries at the bottom level. Yeah. But when you move level higher and higher, it becomes quickly, the number of nodes reduced quickly. Right? Yeah. And how many comparisons you need to do to find a record stay at the bottom? Yeah, because eventually you need to reach the bottom to find the location of the record. Depends on the level number. Okay? So if you have, so the top level you corresponds to 0, then level 1, level 2, level n. Okay? Yeah. So you only need to do comparisons, one comparison for one level. How about that? So you quickly, one comparison, you can move to the next level. After one comparison, you move to the next level. Okay? With the total number of level numbers, then you do what? You do n plus 1 comparisons, right? Yeah, because 0 level, you need to do one comparison. Okay? Yeah. You need to do n plus 1 comparisons. Okay? Yeah. This n number usually not very large. Okay? Yeah. 4 and 5. Yeah. 4 and 5, you can already cover large number of entries. How good it is, think about. So that's the multi-level approach. When we store primary index files using this multi-level structure, data structure. Very efficient. Okay, very efficient. Yeah. 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 Here I do not give you the details. Yeah. How to move from one level, another level. All right. Then, because here today we only have 5 minutes. Yeah, let me just use this 5 minutes to talk about when the data is added and deleted, then what operations do we need to do in our multi-level data structure? Yeah. B tree, B plus tree. Yeah. Yeah. Here, let me just talk about a B plus tree. Yeah. Because B tree, that's the early design. Later, people improve it to get a B plus tree. Then, nobody uses B tree. Okay? just use B plus tree. All right. Here, I give you the high-level idea for these two operations, insertion and deletion, okay? Insertion and deletion. Yeah. We need to change the structure of the multi-level index, but the design is very smart. Yeah. The design is very smart. So when we make the change, we only do local change, not global change, okay? Yeah. So here, after deletion, insertion, deletion, we only do local change. On the B plus tree. Not global change. What's that? Local change, yeah. So you only change, so the current node, okay? The current node. When you do insertion, under some condition, yeah, because think about it, when you insert more and more entries into the node, each node can contain multiple entries. Yeah, so here, the structure. Each node of the tree usually contain multiple, not one entry, multiple entries. Yeah. Why do that? Yeah, because the idea is very simple. Each node, usually you leave some rooms for entry insertion. So you leave some room. Yeah. When you leave some room, when you insert a new entry, you do not need to split. Okay? Yeah. You just insert it, then you're done. That's very fast. Yeah. But there is a capacity for each node, right? Yeah. There is certain capacity. You cannot insert too many entries into one node. Sooner or later, the capacity will be filled, yeah, right? Then split. When it is full, you split that node to two nodes, okay? But when you do a split, you need to adjust nearby nodes. Yeah, so that's pretty complicated. You need to adjust slightly. You know, promote. You know, yeah. So down, promote. All right. Yeah, it's pretty complicated, but you just do local change. Okay. Yeah. Most of the time, you do local change, not too many. Do the change nearby, around the node that you insert a new entry. Okay? Yeah. You do the local change. Yeah. All right. Yeah. Yeah. So that's the insertion. Deletion, when you do deletion, so you delete one of the entries in one node, inside one node. Okay? So you just delete it. Yeah. But when you do deletion, yeah, think about, you do not want to make one node contain too few entries. Yeah. Because if one node, if you do not store enough entries, a lot of space is wasted, right? If one node you do not store many entries, then you waste too much space. That's another factor, not efficient. So what do you do? So those people design, yeah, so let me look at the time. Oh, already 10, all right. Yeah, so let me finish it. Yeah, people use 1/2 of the size to control. Yeah, you must use at least 1/2 of the size of that node. If below that 1/2 size, you merge two adjacent nodes. Something like that, okay? All right, yeah, so let's just get this much information. Yeah. You only need to know there is some algorithms to handle the complexity of those operations. Yeah. All right, so that's it.